In the pursuit of enhancing the secret messages project from the YByte Python curriculum available at www.ybyte.in, let us see how we could decode the Vigenere cipher that we looked at in another video. Vigenere cipher is a generalized version of the Caesar cipher where we shift every letter by a different amount. The amount that we shift is given by this list called key. So, for example, we had the string called turn right, and the key was 1, 2, 3, 4. So T was shifted by 1, U was shifted by 2, R was shifted by 3, and so on and so forth. Now the question is, how do I decode this? In fact, the decoding picture comes very clear when we realize that this is really nothing much but a Caesar cipher. All we need to do is, for example, to turn I take my coded message and shift this, say, for example, by 25. Next letter by 24, next letter by, say, 23. And that is because the key here determines how much shift has been applied to it. 26 minus this key will give me back the original letter as we have seen in Caesar cipher, because really this is a generalization of the Caesar cipher. So what I'm getting at is that in order to decode, all I need to know is this key. I need to compute a new key from this, which is nothing special. It's just 26 minus every element of this key. And then once again run a Vigenere cipher with that key. The code is going to look something like this. Now here what I'm doing is I'm taking the key as an input still. I create a new function, Vigenere cipher decode. Now first thing that I do is to compute my new key, which I call a decoding key, also the D key, which is, element by element, just 26 minus this is the original key, the encryption key. And thereafter, all I have to do really is to, instead of using this key over here, I have to use the D key, and everything else remains exactly the same. Now, at this point, I do want to highlight that some of you may want to do this differently. You can actually compute the key outside, and then you can use the same Vigenere cipher as we had done earlier. But what we will do here is this approach where I keep a separate function for, say, decoding. So let's just see this working, and that makes it more clear. So I go into my code here. I just copy this entire Vigenere cipher, and I call a new function, call it, let's say, Vigenere cipher, say, decode. Now, remember, the first thing I'm going to do is to, have, let's say, a D key created, because given the original encryption key, I must create this D key. This D key has the exact same length as the key. So I just first populated with zeros, of that many zeros. And now I will update this D key by just running a for loop over it. So I say for I in range, for example, say range, let's say len of, say, D key, or could actually use key as well. It doesn't really matter. I'm going to say, look, D key, I is equal to 26 minus key. This 26 is not a magic number. It's coming in because we have 26 alphabets in the 26 letters in the English alphabet. Now, once I've done this, my D key has been computed. All I have to do really is to use a D key over here instead of key, and that should be pretty much about it, because really, remember, I just have to unshift every letter based on what is on the D key, and the previous function was taking care of this part completely. So I just modify the key to D key and I should be done. So let's see this working. Let's say I use my Vigenere cipher function, Recipher. Oh, mistake here. Vigenere cipher, say turn right, and I use a key, let's say 2, 3, say 8, and say 12. Now really the key could be anything. Let's say I did this. Now my xv looks rather complicated. For example, notice there are two z's over here, but clearly they have not come from the same letter, and that's just because each one has been shifted by different amount. Now I want to decode this, so I say, okay, look, xv, for example, underscore d. This okay, let me just use an arrow key up here, so I get this. Now I'm going to say, okay, look, I'm going to first call the decode function. So I call this decode. Now I do not want to decode the original string. In fact, I'm going to decode the coded string. So I'm just going to say, look, please decode for me xv. I send the same key in here, and I call this, say, xvd. When I look at xvd, indeed I get the answer, which is turn right. Now this is really not magic. It's very, very logical. Every letter was shifted in a certain way. I just unshifted it in a sort of complementary way so that it comes back to where it went from. I hope you found this interesting and engaging. In general, if you find that this way of learning excites you, please look at our website. We have lots and lots of activities that can make programming a lot of fun. Take care. Thank you so much. Bye bye.